Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. You can find information about online seminars and study manuals for exams PFM, IFM, and LTAM at the URLs or internet addresses that I list here. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam LTAM. This is problem number 5 from written answer section of the last exam LTAM from spring 2019. A 5-year term life insurance policy with a partially accelerated critical illness CI rider is sold to a healthy life age X. The policy is to be profit tested using the multiple state model, and the states are state 0 healthy, state 1 diagnosed with critical illness, state 3 dead without going through critical illness, and state 2 dead after going through critical illness. Note that there is no return to healthy state from critical illness, and states 2 and 3 are absorbing. In fact, there are no returns here, basically. In every state, once you leave it, you can't go back, and states 2 and 3, every state, state 0 and state 1, once you leave it, you can't go back, which is more important for state 0, of course, in this context. So there is no recovery. You don't go back from critical illness to being healthy, and states 2 and 3 are absorbing. The policy pays $600,000 at the end of the year of critical illness diagnosis if the policyholder is still alive at the end of that year, and $1 million at the end of the year of death if the policyholder was in state 0 at the start of the year, and $500,000 at the end of the year of death if the policyholder was in state 1 at the start of the year. Annual premium of $30,000 are payable while the policyholder is in state 0. You are given the following profit test assumptions. 1-year transition probabilities at age x plus k for k equal to 0, 1, and 2. So where the probabilities are for ages x plus 1, and x plus 2. Is P01, so transition from state 0 to state 1, is 0.01 plus 0.002k. P02 is 0.008 plus 0.003k. P03 is 0.004, and P12 is 0.25. The state-dependent reserves are at time to reserve in state 0 is 12,000, at time 3 and 9,000 in state 0, as time 4 reserve is 5,000 in state 0, while in state 1 the reserve time 2 is 280,000, at time 3 it's 210,000, and at time 4 is 120,000. Pre-contract expenses are 500, commissions are 5% of each premium, including the first. Maintenance expenses in state 1 are 100 at the beginning of the year. The insurer earns interest on investments of 6% per year. The hurdle rate, which is the rate used for discounting profits for calculating present value of profits, is 10% per year. So it's effectively a cost of capital rate, and that's why it's used for profits. So part A question is, show that the emerging profit in year 3, conditional on being in state 0 at the start of the year, is 4,900 to the nearest 100. You should calculate your answer to the nearest 1. Part B showed that the emerging profit in year 3, conditional on being in state 1 at the start of the year, is 14,200 to the nearest 100. You should calculate your answer to the nearest 1. Part C, calculate the profit signature value for year 3, pi 3. Part D, you are given the first 3 values of the profit signature. So pi 0 is negative 500. These are the kind of time 0 setup expenses. There is no profit at that point. Pi 1 is negative 770. Pi 2 is 3,536. Calculate the partial net present value for the first 3 years, NPV of 3. And here's the solution. For Part A, the emerging profit in year 3, conditional on being state J at the start of the year, is, the profit is, well, this, I like to say that this should remind you of the recursive reserve formula. We take the reserve plus the premium minus expenses, accumulated with interest, and then we take out whatever benefit payments need to be made and whatever reserves are needed at the next time. And after those payments, what is left is the profit for the year. Normally, how do you do the recursive reserve? Well, you take the reserve plus premium minus any expenses accumulated with interest, and what do you get out of this? Well, you get the benefit payments if it's a discrete policy at the end of the year, and whatever is left to reserve is the reserve. But here we add this profit dimension, and basically what we're saying is, well, there is the reserve we'll have next year, but if there's any money left, that's a profit to the insurance company. That's basically the main story. The interest rate earned is the earned interest rate that we take into account. That's 6% here. For state 0, we have the reserve at time 2 is 12,000, the premium 30,000, the expenses are 5% of premium, so 1,500. The expected value of the benefit for situation when it transition from state 0 to state 1 is the probability of that transition times 600,000, so that's 8,400. For state 2 is the probability of transition times the benefit in that state, and that's 14,000. For state 3 is the probability of transition there and times the benefit, and that's 4,000. Also, the expected value of reserve, if the transition happens from state 0 to state 0, if you remain in state 0, at time 3 is the probability of that transition from state 0 to state 0, or remaining there, times the reserve in state 0 at time 3, which is 1 minus the probability of going somewhere else. So other 3 possibilities, times the reserve, and that comes out to be 8,712. And the expected value of the reserve upon transition from state 0 to state 1 is the probability of that transition times the reserve in that state, which is 0.014 times 210,000, and that's 2,940. And therefore the profit is previous reserve plus the premium minus expenses accumulated at the interest rate that is earned, minus all the payouts in of benefits in various situations, and all the reserves that are kept. And all the values we just calculated, we subtract them all, and then we end up with 4,878, which is 4,900 to the nearest 100. For Part B, for State 1, we have the reserve at time 2. In that state is 280,000. The premium payment in this case is no payment because the payments are made only in State 0 of premium. The expenses are 100. So the expected value of the benefit also in that state is probability of transition from State 1. The expected value of the benefit in case of transition from State 1 to State 2 is ending up there in time 3 is the probability of that transition times the amount of benefit, which is 500,000. That's 0.25 times 500,000, so 125,000. And the expected value of the reserve upon transition from state 1 to state 1. Remember, you can't go back to state 0, so nothing to worry about in this case. About that, so it's only you either die or you stay in the critical illness. That's the probability of remaining in state 1 times the reserve in that case. So 1 minus 0.25 times 210,000, that's 157,000. Therefore, the profit in this case is the previous reserve minus the expenses, there's no premium, accumulated at the interest rate earned, minus the two the payout and of benefit and the reserve, expected reserve. That ends up being 14,194. This is 14,200 to the nearest 100. And now for part C, the profit signature value for year 3, pi 3, is the probability of being in state 0 times the profit corresponding to state 0, and the probability of being in state 1 times the profit corresponding to state 1. The probabilities are at the beginning of the year, the profits are as of the end of the year, and then we calculate the probabilities that are involved here, so that 2px00 is probability of going from state 0 to state 0 in the first year, and then probability of going from state 0 to state 0 in the second year. Remember, you can't go back to state 0, so we don't have to worry about other states. And that's 1 minus the probability of leaving state 0 through all the other options, times 1 minus, again, the probability of leaving state 0 through all the other options, and that ends up being 0.951594. Now, the probability of being in state 1 is the probability of going from state 0 to state 0, and then going from state 0 to state 1, multiplied, plus the probability of going from state 0 to state 1 times the probability of going from state 1 to state 1. We plug in those values, and we get 0.019236, and therefore the pi 3 value is the first probability times 4,878 plus second probability times 14,194, and that's 4,914.91. And then for part D, the partial net present value for the first 3 years. It's partial because there could be future possibilities, but for the first 3 years, that's negative 500 from time 0, minus 770 over 1.1. Remember, we always discount profit at the hurdle rate, which is 10% in this case, plus 3,536 over 1.1 squared, plus 4,914.91 over 1.1 cubed, and that ends up being approximately 5,414.96. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies, and good luck on the test.